A solar cell, also known as a photovoltaic cell or PV cell, is basically a PN junction diode. A very thin layer of P-type semiconductor is grown on relatively thicker N-type semiconductor. The working principle is that as light reaches the PN junction, the light photon easily enter into the junction through a very thin P-type layer. The light energy in the form of photon supplies sufficient energy to the junction to create a number of electron-hole pair, thus break the thermal equilibrium of the junction.
Has three layers: P-type layer, intrinsic layer, and N-type layer. Typically, this junction is fabricated from amorphous silicon. The thin film silicon solar cell consists of a p-doped layer, an intrinsic layer, n-doped layer sandwiched between a front transparent conductive oxide (TCO) and a back conductive contact, either TCO layer or a metallic contact. The whole structure is supported by a substrate, example glass, metallic, or a plastic foil.
Provide a simple way. This simple way lead to improve the absorption ability with a thickness intrinsic region. Moreover, the structure can benefit from a wide intrinsic layer, which can improve efficiency without increasing cell thickness. Compared with conventional thin film, the pin diode lateral structure exploits direct light irradiation on the absorption layer, one-sided contact, and bifacial irradiation.
In pin device, there is a amorphous silicon layer. It will balance the holes and mobility. It will also increase contact area of PN junction. Excess carriers produce photocurrent. Each photon absorbed creates one electron-hole pair. Pin solar cell converts photocurrent into electrical power to a load. Having an intrinsic layer will also stabilize the silicon layer.
When energy comes from light is absorbed by semiconductor, it will dislodge an electron, creating an extra mobile electron and an extra mobile hole, which is created at the depletion zone. The electric field makes the electron flow to the N-type material and the hole flow to the P-type material. This is known as photogeneration of charge carriers and occurs throughout the N-type and P-type semiconductor. When we connect any load between these regions, electrons will start flowing through the load. The electrons will recombine with the holes and p regions after completing their path. This way, solar cell gives continuously direct current.
For a solar cell to generate electricity, it requires carriers, and generation of carriers in a PIN diode cell, solar cell, is due to the excitation of electrons by absorbing the photons to produce electron holes pairs, which is a process called the photogeneration. When light is removed from the PIN junction, photogeneration of electrons holes pair cannot occur due to the lack of photon, and there will be no carriers that is generated, so the solar cell would not be able to generate any electricity.